In this example, trying to find the indefinite integral for a given function, we're going to use the three rules that we've covered in class so far, and in this example, focus on the first two. So we'll begin by rewriting it as an integral. The integral of 3 over 4 x to the minus 6 dx. Now, rule 2 says we can take the constant outside, so we're going to remove the constant, then integrate the remaining function, which we do by following rule 1, add 1 to the exponent, and then divide by the same exponent. So 3 over 4 x, the exponent is negative 6, so plus 1 gives minus 5 over minus 5 plus the constant of integration. Simplifying, we end up with negative 3 over 20 x to the power of 5 plus a constant. In the next example here, we're going to have to use all three rules since we have the sum of three separate functions, and using rule 3 we can treat it that way. So we'll start by writing it as an integration, and notice when we do this we have to include the dx with each term rather than just at the end. So to do that, we can close that in brackets. Now, using rule 2 and 3 at the same time, we can separate each function and take the constants outside. So 11 times the integral of x squared dx plus 2 times the integral of x dx plus 9 the integral of dx. Treating each piece separately now. The first one, we keep the 11. X squared becomes 2 plus 1 is 3 over 3 plus 2. X to the power of 1 becomes x to the power of 2 over 2 plus 9. The integral of dx, we can look at it two ways. We can call it x to the power of 0, which becomes x to the 1 over 1. Or just think in our heads, what gives us a derivative of 1? And that would be simply the variable, so in this case, just x. As always, we need a constant of integration, and simplifying gives us 11x cubed over 3 plus x squared plus 9x plus c. In this example, we're using the same rules, so it's just a little more practice. So we'll start again by writing it as an integration, remembering to enclose it in brackets. So that the dx is applied to each term. Writing it as 4 separate integration questions and removing the constants gives us the following. Make sure to write the dx with each term. Every time we write an integral, here we should have the 4 outside. Every time we write an integral symbol, it must have a dx or a d with some variable. Integrating now, using rule 1 for each of the integrals, we end up with 7x to the 5 over 5 minus 9 over 5 stays, x to the 4 over 4 plus x. 2 over 3 plus 1 is 5 over 3 over 5 over 3 minus 4x plus a constant. Simplifying as much as we can gives us 7x to the 5 over 5 minus 9x to the 4 over 20 plus 3x to the 5 over 3 over 5. We reciprocate that term. Minus 4x plus a constant.